Hi there. Today we'll be presenting our database, which is called Database System for Wireless Charging Electric Vehicles, created by myself, Grant, Ishwar, and Bhargav. You can change.
Yeah.
Okay. First of all, the purpose of our idea is to provide a more efficient and convenient method of charging vehicles for electric car owners. Now I will list a few conveniences of our design. It uses start and end locations of trip to calculate amount owed by customer through electric grid. Electric grid generates a token which tracks amount due and amount of charge obtained by the customer. And also, it's much faster than traditional electric car charging. Next, I will list the reasons for why a database is necessary for our idea. The database is needed to track the history of each customer, as well as separate customer transactions for clarity, update information about customer tokens such as location and billing, and store local information to each base station for organization. Now I will review our problem statement. Since their first introduction to the consumer market barely a decade ago, electric vehicles have rapidly grown in popularity. Fast or instantaneous charging would widely increase the appeal for electric cars on the market. There are challenges involved in creating and managing such a system, which could accommodate tracking various entities and ensuring robust payment tracking. And that is our problem statement.
This is our old ER diagram. While going through our old ER diagram, we face some integrity constraints like, in case the customer vehicle is stolen, what if somebody is taken and he will be getting charged? So by using the cascades, we overcome is that the vehicle ID as well as the token ID and the customer ID is both are equal from the T tables, then only it get charged. If not, the account will not be charged. What if the token fails to generate from the base station? Then the customer will be notified by getting a generate or from the trigger get an error like this. The token is not generated, so you can try again. Using the cascades, we overcome this by like the token ID in the vehicle ID and the vehicle ID in the vehicle should be equal, as well as in the customer ID in the customer table should be equal with the token in the token table customer ID. Then only the customer can able to charge it. I'm done with the cascades.
Yeah, so this is the new ER diagram. So this is basically an extension to the old ER diagram. However, we made a significant change by adding base station, which pretty much connects the electricity grid, token, vehicle, customer entities. So electricity grid manages the base station based on the start and end location, as well as it takes care of the token generation. So whenever a token generation is failed, then the customer will be notified by the base station, as well as once the token is issued, then the customer the token is directly issued to the customer table. So these entities are pretty much managed by the base station, and it's basically the heart of the new ER diagram. Moving on to the next slide.
The normal forms, when going through a ER diagram, we got some violations in normal forms like 1NF, where is a multi-variable attribute which can be formed in the vehicle ID. One customer can have multiple vehicles. So we divided that one, we overcome the one normal form, and we got up the BCNF. While going through the customer trip and billing, there is a violation in the BCNF. So by going through the rules, by considering the customer billing and trip, we followed the rules by dividing it, and we overcome the BCNF as well.
So we created multiple views in this. So this view basically talks about the customer as well as vehicle association. So this has the respective customer ID as well as the vehicle ID. Moving on to the next view. So this view is accumulation of both trip and base station. So whenever a base station is assigned with the start location and end location, so the trip ID generates that, and based on that start and end location, a particular a specific base ID is assigned to that. So this view talks pretty much about this functionality. Moving on to the next slide. So we have created a couple of triggers as well. So this trigger in general, so whenever a token, a trip ID is generated, then that trip ID is responsible in generating a token to that particular customer vehicle. So this token is directly issued to the customer account. So this is the trigger. Moving on to the next trigger. So in this trigger, if the start location and location specified by the customer is same, then it will throw an error stating that these both locations are same and this is an invalid input. So it will ask the customer to change. So this is one of the trigger. And so the roles and responsibilities of the project. Basically, I, Ishwar, worked on the ER diagram. Bhargav took care of the DB schema as well as the implementation part, and Grant worked on identification of FTs and normal fronts. And apart from that, everyone has equally contributed in other parts of the project. So this is about our project. Thank you.